Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, today we are going to proceed with the chapter angle properties. Okay, circle theorem. Okay, now, in this topic, there are 5 important properties of in circle theorem that you need to know. Okay, number 1. Okay, we call angle in semicircle. Okay, what does it mean by angle in semicircle? Okay, the rule said if given, let's say, one circle, okay, now in order to make it into semicircle, what does it mean by semicircle? Meaning that we cut the circle into half. So meaning, let's say this is point A and this is point B. Point A and point B cut the circle into half to make it into semicircle, where it must go through the center of the circle. Okay, so now I have the semicircle, half up here and another half down here. The first properties, it says that if you have one diameter in the circle, okay, if I want to make a triangle, let's say I want to project from here until touch the circumference, then go back to B. I say point C is here. This is point C. Okay. If you notice, point A, B, and C, all of them lies on the circumference. Okay, all of them lies on the circumference. This type of points we call concyclic points. Okay, point A, point B, and point C, they are lies on the circumference, so they are concyclic points. What is the special about this triangle? It says that when you have one diameter, okay, and then when you connect into A to C, B to C, automatically the angle formed over here will be 90 degree, with the condition point C must lies on the circumference. Okay, then it will make 90 degree. But if, example, okay, for example, number A, if given this type of circle and then you have the diameter, okay, okay, nice, okay, you have the diameter, okay, let's say this is from P to Q, and then suddenly point R is somewhere over here. This is point R. If you connect from here to R, let's say R is somewhere over here, this value is not 90 degree, which is not right angle triangle. Okay, why? Because point R is not what we call concyclic points. Okay, so the condition to make it right angle triangle, it must be on the circumference. Okay, point C can be anywhere. It also can be like this. Example number B, it also can be, if you have the circle, okay, this is the diameter. Over here, I put point C over there, right? Point C also can be down here. It can be here, as long as it touch the circumference. So here is 90 degree. It also can be here. This is also 90 degree. It also can be here. This is 90 degree. It also can be here. This is 90 degree. If you notice, all of the points here, they are lies on the circumference. Then you can apply the properties number 1. It says that the angle in semicircle, the moment you connect from A to C, from B to C, automatically it will create right angle triangle. Okay, example, let's say if they have this question, given the value over here is 20 degree, okay, then this is the center, of the circle, then here is the value of x. Then the question, find what is the value of angle x. The only information said over here is this is the diameter line. Okay, so based on the theorem number 1, it says that whenever you have semicircle and then the point C lies on the circumference, which is right over here, automatically this value will be 90 degree, which is right angle triangle. Okay, so by that we can find the value of angle x. Okay, how to find the value of x? So we know that this is the right angle triangle, so the sum of the interior angle for the triangle is always 180. So this is going to be, so the solution, so this is 90 degree. So we know that 90 degree we plus with the 20 degree, when you plus with this x, the sum must be 180 degree. Okay, you rearrange, you solve for the value of x. So x is going to be, so 90 plus 20 is 110, so it's going to be 70 degree. So the value of x over here is 70 degree by using the properties number 1. So the angle over here is 90 degree. Another example, they also can ask something like this. Let's say this is circle. Okay, let's say I want to extend the line outside here. Okay, so this point, let's say this is point P, then here to here, this is point Q. Okay, so we know that this is 90 degree. So let's say the angle over here is 40 degree. X is somewhere outside here. This is x. Okay, so this is point R, PQR. So this is the center of the circle. Okay, given that PQR is right angle triangle, how to find the value of unknown x? So since we already know that the angle at Q is 90 degree, so in order to find what is the angle x, so the solution for this question, what you need to do is just find what is the unknown value over here first. Okay, so this is 40, this is 90, so we can easily find what is the value for this part. Okay, so it's going to be, we know that this is the triangle, so let's label the angle over here is angle y. Let's find y first. So 90 degree, when you plus with 40 degree, when you plus with y, it always must be 180. So in order to find y, so 90 plus 40 is 130. So we need another, so 50 degree. So 50 degree is for this value. So this is 50 degree. How to find y outside here? Okay, so in order to find y, we know that this line is straight line. So the sum of x and y, since it is lies on the straight line, must be 180. So x is going to be 180 minus 50 degree, which is equal to 130 degree. So x, which is outside here, is 130 degree. So this is properties in circle theorem number 1, angle in semicircle. The next, okay, what if they have another circle like this. Okay, circle number 2. Properties number 2. Okay, properties number 2, we call the angle in the same segment. What does it mean by that? Angle in the same segment. It means like this. If given to you one circle, okay, this is circle. Okay, let's say I have concyclic point. Always remember, concyclic point meaning the point that lies on the circumference. Okay, from AB, let's say it go up there. Point C is somewhere up there. Okay, so this is point C. Okay, from A, C, then go to B. If the value of angle over here is x, okay, A, C, B, the angle here is x, okay, then automatically A D B also will be x. Why? Because this is the segment that they use, the segment AB. They are coming from the same segment. So angle ACB, so we can say that angle ACB is equal with angle ADB, because they are coming from the same segment. Example, let's say question give something like this. Okay, then over here is 30 degree, over here is y. Find the value of angle y. Okay, one more thing you must remember, if you look over here, the intersection between them, the line AC and the line DB, is not necessary midpoint or the center of the circle. No, okay, it can meet anywhere as long as it's coming from the same segment. Identify which segment they are using. So this is the segment. So since A, let's label A, B, C, D. Okay, since ABD is 30 degree, so try to guess what is AC, ACD. They are coming from the same segment. Yes, so the value of y, angle y, is also will be 30 degree. What if they go the other way? Instead of up here, down here. Okay, down here. So let's say over here the angle is 50 degree. This is x. What is the value of angle x? Okay, so same like this, what you need to do is identify where is the segment. Identify where is the segment. So based on this one, what you can do is you can always rotate the circle in your point of view. Okay, if not, you just can see from here. I know this is the segment that they use. So from here, go here, come back here. From here, go here, come back here. They are coming from the same segment. So we know that since it's coming from the same segment, the value of angle x also will become 50 degree. If the angle over here, let's say this is 10 degree, for example, and then over here is y. What is the angle y? So the angle y becomes 10. Why? Because this is this segment, another side of segment. How does it look like? This segment go to 10 degree, this segment go to y. So they are coming from the same segment. With the condition, you must remember all point over here, A, B, C, D, they must be concyclic points. What is concyclic points? The points that lies on the circumference. Okay, so this is number 2, properties number 2. Let's have a look properties number 3. Okay, properties number 3, angle in the same segment, done. Okay, properties number 3, angle in opposite segment. Okay, what about the angle in opposite segment? This is angle in the same segment. The next one, in the opposite segment. How does it look like? Okay, example, this is the circle. Okay, I will have 3 points A, B, C, D. Okay, I must make sure all those points lies on the circumference A, B, C, and D. Okay, now angle in opposite segment. It says that if I connect from D to A, this line DA we call chord. Okay, and then from A to B, from B to C, and from C to D. Okay, if you look over here, inside this circle, it looks like quadrilateral. Okay, this quadrilateral we call cyclic quadrilateral because point A, point B, C, and D, they are concyclic points. Okay, what is the properties of opposite segment? It says that if given cyclic quadrilateral like this, okay, the angle A, opposite of the angle A is angle C. So angle A and angle C, they are opposite between each other. Angle D and angle B, they are opposite between each other. The properties said the opposite angle AC, BD, they are supplementary between each other. What does it mean by supplementary between each other? It means that when you add, okay, when you add up the angle, okay, when you add up the angle, it will be 180 degrees. So meaning that the angle A, when you add with angle C, it must be 180 degrees. Angle B, when you add with angle D, the opposite between each other, they must be 180 degrees also. Okay. Okay, now example, if question asks something like this. Okay, now let's say this is cyclic quadrilateral. Over here is 60 degree. Over here, this is not to scale, okay? Over here is 80 degree. This is A, this is B. Okay, find what is the value of angle A and angle B. Okay, value of angle A and angle B. So based on this one, what you need to do is you just need to identify which one is opposite with which one. Okay, so I can see that A and 90 degree, A and 60 degree, they are opposite between each other. B and 80 degree, they are opposite between each other. I will apply this rule. It says that when we add up the angle, it will become 180. Let's find angle A first. So A, this is the opposite. Okay, so A and 60, they are opposite between each other. So we know that when angle A plus 60 degree, it must be 180. So rearrange. So A is equal to 120 degree. Same goes to B. So when B plus with 80 degree, it is equal to 180. So B is equal to 180. 100 degree. Some students, they are confused when it say that the angle in opposite segment. Okay, opposite segment. They have confusion which one is the segment they are talking about. Okay, look over here. It says that angle A and angle C, they are opposite. But over here is mentioned opposite segment, not opposite angle. Where is the segment? This is the segment. Look carefully, okay? Segment for A. From here until here. Okay? Then, if you look over here, from D, I go to B. Then I project to A. So this is the segment for angle A. Up here, this is the segment for angle A. Where is the segment for angle C? The opposite way. Meaning that another side. Over here. This side. Okay? This side. So it go to angle C. See? You notice? This is opposite segment with this one. So that's why they say opposite segment. It looks like opposite angle, right? But actually it is opposite segment. Based on this one, where is the segment? This segment is for the 60 degree. This segment is for angle A. So this is what does it mean by opposite segment. This is properties number 3. Okay, let's have a look properties number 4. There are 5 important properties that you need to know. Okay, properties number 4. Okay, properties number 4. Okay, we have already angle in the semicircle, angle in the same segment, angle in the opposite segment. Okay, next, angle at the center of circle. Angle at the center of circle. Okay, what is the property said? It says that if given one circle, okay, so this is the center. Center is here. I have point A here. I have point B right over here. Okay, if I make a radius from A go to the center, so this is radius from center go to B. This is also the radius. Okay, if this angle, let's say 2x, okay, look carefully. From A, B, O. This is center O. Okay. From A, B, go to the center. If the angle is 2x, from same segment AB, now I project to the circumference. Let's say somewhere up there. We project to the circumference somewhere up there. The angle over here will be automatically half of the angle at the center. If this is 2x, this one becomes 1x. Okay, with the condition it must coming from the same segment of AB. Okay, example for this one. Example, it can be like this. If they give you a circle, okay, from here go to the center. This is center. If the angle, say that find the value of x over here, given that over here is 100 degree. Okay, based on this one, by using this theory, he said that the angle at the center and the angle at the circumference. Okay, if the angle at the center is 100 degree, the angle at the circumference must be always half of the angle at the center, half. Okay, so meaning that center over here is 100 degree. So the angle at x will become half of 100, which is 50 degree. But you must remember, for this theorem, the circle also can go this way. You see, still this is the center. If you look over here, A down there, B down here. A and B can shift, can be anywhere as long as on the circumference. Okay, so this is the radius, this is the radius. Okay, just now over here I go that side, then this is x, right? So meaning that, let's say I want to go this way, I want to go this way. So let's say this is point C. Now point C is here. You see the major sector over here, the major sector. Okay, if the angle over here is 2x, where is the angle of half of the 2x? Right over here. So this is 1x. If you look over here, I use the minor sector. If you look over here, I use the major sector. So it can be in two different situations. Example like this. Okay, you see the circle. So go to the center. Where is the center? Go to the center. Okay, go up there. Let's say the angle over here, I want to put x. The angle over here is 60 degree. Okay, my question is find the angle of x. Okay, bear in your mind, this type of shape is following this one. Okay, if you look over here, x is here, 2x is right over here in the major sector. If you look over here, 60 is here, 60 is here. Angle at the circumference is 60. So we know that angle at the center must be twice as angle at circumference. So where is 120? It's not x. Okay, 120 is right over here. So this is 60, this is 120. So since this is the circle, we know that the complete circle is 360. So this is 120. So we can calculate. So x is equal to 360. You just minus with 120, which is equal to 240 degree. So the angle x here is 240, not 120, because the angle following over here is in the major sector. For this case, in the minor sector. So be careful. Okay. Okay, next. Theorem number 5. Theorem number 5. It says that the angle between radius and tangent line. Radius and tangent line. How does it look like? Just like this. Let's say I have circle. Okay, I have circle. Then what does it mean by tangent line? This is the tangent line. Okay, it must touch the circumference. Let's say I have another tangent line over there. Okay, so this is tangent line. This is tangent line. This is the center of the circle. Okay, from the center of the circle, if I draw one radius, go over here, go over here. Okay, this is the radius, this is the radius, this is the tangent line. What is the property said? It says that the angle between the radius and the tangent line, which is over here, automatically will be 90 degree. Automatically will be 90 degree. Okay, if I cut this, let's label. Okay, I say over here we call point P. This is O. This is Q. Let's say over here is R. If I cut like this, if you notice, when we cut this way, I make it look straight. Okay, when we cut this, okay, P O R, Q O R, they are what we call congruent triangle. Congruent triangle. What does it mean by congruent triangle? Congruent meaning they are same or they are exactly copy paste between each other. What does it mean by that? It means that you see this triangle, if the length of radius is 4 cm, over here also will be 4 cm. If the length of PR is, I put random number, let's say 15 cm, automatically the line of QR also will be 15 cm. If the angle, what about the angle? If the angle in POR over here, let's say if the angle over here is 20 degree, automatically the angle over here also will be 20 degree. Okay. Then if the angle over here 70 degree, automatically the angle over here also will be 70 degree. So if you compare the two triangles, they are exactly congruent between each other. What does it mean by congruent? The length of the side is equal, even the angle inside also equal. Exactly, everything is the same. Okay. Example question. If they give something like this, here's the tangent. Okay, let's make it nicely. So this is the circle. So this is the tangent. This is the tangent. Okay. So this is go to this radius. This is the radius. So let's say this is the x. This is the radius. Okay, now in order to find the value of x, here is 90 degree, here is 90 degree, then let's cut it into two. Okay, so if I give you the angle, the whole angle over here, the whole angle over here is 100 degree. Alright, this side, okay? 100 degree. 100 degree is the angle here. This is the angle 100 degree. Okay, x is here. This is x. How to find the angle x for this case? Okay, now if you look over here, what can we do is we can split the triangle into two. So this is first triangle, this is the second triangle. Since the total angle here is 100, we know that this is 50, this is 50. Okay, so 50, 90, since the x is the whole thing, let's calculate half of it. Okay, so let's take the first right angle triangle, the top part. So the first right angle triangle, the top part just like this. So this is 90, so this is 50 degree. Let's find the small part over here. So automatically we know that 50 plus 90 plus over here, it must be 180. So by calculation, so we know that the angle over here is 40 degree. 50 plus 40 plus 90 equal to 180. So this 40 degree is the angle over here, small angle over here. This is 40 degree. Okay, this is 40 degree. So since we know that they are congruent, if the angle here is 70, here also must be 70. So if here is 40, below here also must be 40. Then what is the answer for the angle x? So 40 and 40 becomes, so the final answer, so x based on this one, 40 plus 40 is equal to 80 degree. Okay, so these are all 5 circle theorem that you need to know. Okay, after this I will show you how to combine all of this theorem in one question. In IGCSE, usually they combine the whole theorem and then you need to look which theorem is applicable on that question. Okay, so in our next video I will show you the sample of IGCSE question. So that's all for today. Thank you.